Woohoo! It's a great day to be in geometry. I'm Miss Leg Battles, and I'm here today to talk to you about regular polygons and how to find the area of regular polygons. So, what do we need to know before we begin? First of all, we need to know, what does regular polygon mean? A regular polygon is both equilateral, which means all sides are congruent, and equiangular, which means all angles are congruent. Next, let's look at some important vocabulary. Central angles, center, radius, and of course the plural of that is radii, and apothem. First of all, the center of a regular polygon is also the center of the circumscribed circle. The center is shown here on our regular triangle. So now let's look at central angles. A central angle are these angles in the center. All the central angles together would add up to 360. And if we take 360 and divide by 3, that would leave us 120. So these central angles would all be 120. Now, notice the radius of this. Here's a radius in green. The radius of this regular triangle is also the radius of a circumscribed circle. So, the apothem, which we're going to show here in red, goes from the center perpendicular to the side, and it also cuts the central angle in half. So this 120 degree angle is now divided into two 60 degree angles. Now, since it's perpendicular to the side, we have a 60 degree angle, a 90 degree angle, and by triangle angle sum theorem, a 30 degree angle. So we have our special 30, 60, 90 here in the regular triangle, and that's going to help us find area. Now, here we have a regular quadrilateral, also known as a square. To find the central angle, 360 divided by 4 leaves 90. So all the central angles are 90. Notice we have the apothem in red dropped in. It splits that 90 degree angle into two 45 degree angles. Now, in this triangle, I have a 45 degree angle, a 90 degree angle, and by triangle angle sum leaves this one to be 45. So again, we have a special right triangle that will help us find the area, and it's a 45, 45, 90. Last, we have a regular hexagon. It has 6 central angles. 360 divided by 6 gives me 60. Furthermore, all of these triangles that you see drawn in here are regular triangles. I know this because the radii are going to be congruent, so the base angles would be congruent. So look, these are going to be 60, 60, 60 triangles, which of course are equiangular and equilateral, which makes them regular. Think about your pattern blocks. Remember, the big hexagon was yellow, and all the triangles that make the hexagon are green. So as I continue labeling, all these are 60. When you drop in the apothem, it divides this into two 30 degree angles. And now I have a 30, 60, 90, thanks to the triangle angle sum theorem. So notice in my regular hexagon, I have a 30, 60, 90. In my regular triangle, the first one, I have a 30, 60, 90, but they're just turned a different way. So we need to remember, on our triangle, the apothem is the short leg. But on my regular hexagon, the apothem is the long leg, because it's opposite the 60-degree angle, so it is the long leg of this 30, 60, 90 triangle. Next, let's talk about how to find the area of a regular polygon. So let's derive that formula. Pictured here to the right is a part of a regular n-gon with side length s. The radii divide the figure into n congruent isosceles triangles. N is the number of isosceles triangles. Each triangle has a height of a, that's interesting, and a base of s, also interesting. Why do we label them a and s? Because a is the apothem of our regular polygon and s is the side length of our regular polygon. But remember, it's an n-gon. That means it has n for the number of sides. Now, how do we find the area of a triangle? Well, that's easy. It's 1/2 base times height. And the base is s and the height is a. So it's 1/2 times s times a. Since there are n congruent triangles in the n-gon, the area of the entire n-gon is n, that's how many triangles there are, times the area of each triangle, which is 1/2 times the side length times the apothem. Now, since the perimeter of the n-gon is, well, how do we find perimeter? It is the length of the side times the number of sides. There are n sides, that's the number of sides, and the side length is s. So the perimeter is n times s. Now, we can make a substitution to come up with the area of the regular polygon. If we take the n and the s, and here's an n and here's an s, okay? If the perimeter is equal to n times s, that means I can take out the n times s and I can substitute in a p. So my final formula for area of a regular polygon is 1/2 times the apothem times, instead of n times s, the perimeter. So area of a regular polygon is 1/2 the length of the apothem times the perimeter. Next, let's look at an example. If the apothem and side length of a regular polygon is given, you need only find the perimeter and then apply the formula. So when we're given these two pieces of information, it really makes the problem pretty easy. So find the area of each regular polygon with the given apothem A and the side length S. So first, let's write our formula that we're going to need. Area is 1/2 apothem times the perimeter. So area is 1/2. Now, the apothem is 60.4 feet. So apothem 60.4. Now, next we need to find the perimeter. The perimeter is not given, but the side length is given. So if each side of the octagon is 50, we need only know that the octagon has 8 sides, and if every side is 50 feet long, that is 8 times 50, which of course is 400. So now in place of perimeter, I'm going to put in 400. So just get out your handy dandy calculator and let's put that in, and we get the area for this problem is 12,080. Now, since the apothem and the side length was given in feet, our answer will be in square feet. Now, notice in this section of problems that we do not have the triangle, square, and hexagon, which are the special ones where we use the special triangles. But we can find the area for pentagons, decagons, octagons, any other kind of polygon as long as we're given more information. In the future, we may learn how to use trigonometry to find the missing parts so that we can also find area of these pentagons, decagons, octagons, and so on. The next example that I've chosen to look at is finding the area of a regular polygon and then rounding our answer to the nearest tenth. So notice on this one we have a regular triangle and its side length is 20 centimeters. I have already drawn in 2 radii and the apothem. So recall from our previous discussion that we know these angle measures. This angle measure would be 60 because our central angle was 120. 120 divided by 2 is 60. This gives me a nice 30, 60, 90 triangle. If the side length is 20, that means when we drop in the apothem, we cut that in half. So each of these would be 10. In this triangle, 10 is the long leg. Now, if you know the long leg and you're looking for the short leg, and we are because that's the apothem, we just need to divide by the square root of 3. Now, in our previous work, when we divide by square root of 3, we wouldn't leave that radical in the denominator. We would rationalize that. But today, since we're just finding this to the nearest tenth, you really don't need to rationalize first. It's just an unnecessary step. So let's write our formula and figure out what we know and see if we have something missing. Our formula is 1/2 apothem times perimeter, so it's 1/2, and my apothem is 10 divided by square root of 3, and then the perimeter. Now, the perimeter would be 20 times 3 because each side is 20 in the triangle. So 20 plus 20 plus 20, that gives me the perimeter. So for this problem, the perimeter is 60. Now, since we're rounding to the nearest tenth, you need only put this in your calculator and round off. So this turns out to be approximately, are you getting it in your calculator? 173.2, and since the length was given in centimeters, the area would be in square centimeters. Now we have an assortment of problems that are written in words. So I just want to highlight some of these problems so that you can work these. The first one, I went ahead and drew a diagram. Remember, if in doubt, draw it out. And if you have your templates, this would be nice to use your template for. On number 11, it says your geometry teacher draws a regular hexagon with a circle circumscribed around it for a t-shirt she is designing. The radius of the circle is 5 meters. To the nearest tenth, what is the area of the hexagon? So let's look at this radius that's drawn. This radius of the polygon is the radius of the circle. Remember, we talked about that on our opening slide. So on this one, we know the radius. It's given to be 5 meters. And now we can draw in our triangle, drop in the apothem, use our 30, 60, 90s to find the area of the hexagon. Notice on this one we're given the perimeter, so you could find a side length for number 12, and then given a side length, because it's a regular hexagon, you'd be able to find the area. Number 13 talks about a regular octagon. But look, two things are given, the side length and the area, and you're looking for the apothem. So what you need to do is write your formula down, write in everything that you know, and solve for what is missing. And then in the last problem, it's an equilateral triangle inscribed in a circle. So the radius is 6 feet, and again, because it's an equilateral triangle, we'll use our 30, 60, 90s, and you'll be able to find the area. Now, that brings me to our final two examples. These say, find the area of each regular polygon with the given radius or apothem. If your answer is not an integer, leave it in simplest radical form. So these we will leave in simplest radical form. So number 15 is a square. It says they're regular polygons, and of course a regular quadrilateral is a square. And the radius is given to be 8 millimeters. So the first thing I want to do is draw in my triangle. So I'm going to draw in another radius. Then I'm going to drop in the apothem here. Make it dotted. And remember, it is perpendicular. So we'll go back and draw that to be perpendicular. Now, remember, in every square, the central angles are 90. Drop in the apothem, and we get a 45-degree angle. So we have 45, 45, 90s. And the radius is 8, so in my 45, 45, 90, that is the hypotenuse because it's opposite the right angle. So the first thing we want to do is find the length of the apothem. So we know we can find the length of the apothem by taking the hypotenuse and dividing by the square root of 2. Now, this time I am going to rationalize because remember, our final answer needs to be in simplest radical form. So I'm going to multiply by square root of 2 over square root of 2 to rationalize, and that gives me 8 on the square root of 2 over, well, square root of 2 times square root of 2 is 2. Now, next, we're going to divide the 2 into the 8. It goes 4 times, and that's going to leave me with 4 on the square root of 2. So you may remember we had figured out a pattern. If the hypotenuse of a 45, 45, 90 is 8, the legs are going to be half of 8 on the square root of 2. So that's exactly what we found here. Now, let's write our formula down and see what we're going to need. The area of a regular polygon is 1/2 the apothem times the perimeter. So the area is 1/2 apothem. Well, we found the apothem right here, 4 on the square root of 2. That's 4 on the square root of 2 times the perimeter. Now we don't have the perimeter yet. Let's find the perimeter. The perimeter is the side length times 4 in this case. Well, notice if this is 4 on the square root of 2 for the other leg of the 45, 45, 90, then the entire side would be 4 on the square root of 2 plus 4 on the square root of 2. So this side is 8 on the square root of 2 all the way across. So my perimeter would be 8 on the square root of 2, let's write it, would be 8 on the square root of 2 times 4 because there are 4 sides. So that gives me 32 times the square root of 2. So I'm going to substitute that in right here, 32 times the square root of 2. Now, you can certainly put this in your calculator. This one turns out to be really nice. But let me tell you where students sometimes miss this. I would multiply 1/2 times 4 times 32, and I would make note here that when you multiply this square root of 2 times square root of 2, okay, this square root of 2 times this square root of 2, square root of 2 times square root of 2 is square root of 4, which is just 2. So if I take that 2 and multiply by the 1/2, those will divide out. So all that leaves me with is 4 times 32, which is 128, and this would be in square millimeters. Okay? Now, on this particular one, if you put all of this in your calculator, it's going to give you that 128. But we need to be careful when we're leaving them in simplest radical form just to make sure. Now, next, number 16 is a regular hexagon, and the radius is given to be 5 meters. So, first thing I'm going to do is draw in my triangle here, my special triangles. I know these are all little regular triangles. I'm going to drop in the apothem here, and I'm going to label my angles. Remember, again, the apothem is perpendicular. So I'm going to draw that to be perpendicular. Now, all my central angles will be 60. Drop in the apothem, and that makes it 30. So if that's 30 and that's 90, that leaves 60 for this angle. So I have a 30, 60, 90. Now notice the radius is 5. You know, I've drawn my triangle down here. I just like to draw them in the same place every time. So I can label my radius here. So in my 30, 60, 90, the radius is the hypotenuse of my 30, 60, 90. So again, let's write our formula. What do we need? Area is 1/2 apothem times perimeter. Okay, so I have 1/2. Now I need to find the apothem. So let's go back and look at our 30, 60, 90 triangle. If the hypotenuse is 5, the short leg is half of that. Now I'm going to write that as, here, let's change the color. I'm going to write that as 5 over 2. I'm going to divide by 2, but instead of writing 2.5, normally we're not going to mix radicals and decimal notation. So I'm just going to leave, when I take half of 5, I'm just going to put 5 over 2, because I know to get the long leg, I'm going to have to take this short leg and multiply by square root of 3. So that gives me 5 on the square root of 3 over 2. That's the apothem, and that's what I needed here. 5 on the square root of 3 over 2. Now, next, let's find the perimeter. The perimeter is going to be the side length. Well, remember when I told you earlier that these are all little regular triangles? If this is 5, this is 5, and of course if this is half of 5, the whole side is going to be 5. So all the sides are 5 as well. So when I find the perimeter, I just multiply how many sides there are, 6 times the length of each side, which would give me 30, and in this case it would be meters, of course. So the perimeter is 30 meters, so I'm going to put 30 in. Now, let's multiply all this together and see what our final answer would be. First of all, I might take this 2 and divide it into the 30. It goes 15 times. So in the numerator, I have 5 times square root of 3 times 15. So 5 times 15 is 75 times that square root of 3. And in the denominator, I'm left with 2, this 2 right here. And of course, when I multiply meters times meters, I'm going to get square meters. This is area, so it's going to be in square meters. Now, I hope these examples help and that you can finish up the remainder of your examples. Hey, it has been a great day to be in geometry.